So hello everyone, we're the Downtown Dark Ride team. We were tasked with creating a dark ride for the downtown area of the park, and our concept is called Cosmic Countdown, Time Travel Adventure. So we'd like to introduce ourselves to start off. So my name is Liam Olive. I'm going in my third year as a mechanical engineering student at UCLA, and I worked as the attraction manager.
Hi, my name is River Watts. I'm a third year aerospace engineering major at San Diego State, and I worked on the layout for the attraction.
Hi, my name is Jack Keaton. I'm going into my second year at UCLA as a statistics major, and I did the concept art.
Hi, my name is Brian Tran. I'm a third year at San Diego State, and I'm a mechanical engineering major with an emphasis in bioengineering.
Hi, I'm Brian, and I'm studying bio and film in my third year at UCLA, and I was in charge of working on the story and 3D modeling.
Great, awesome.
So this is our attraction poster, and our log line is, guests are sent whirling through space and time to experience the star grove of the past. From navigating dense jungles to the floating highways of chrome cityscapes, guests follow the progress of civilization, but will soon find out that the future is in jeopardy. It's up to guests and Dr. Flabagos to save the day and rescue Star Grove.
So some basic attraction info to start off. Our ride system consists of a tracked EMV motion base, a simulator type ride through the dark ride environments. The attraction size, including all queue space, is around 170,000 square feet. The attraction length, not including the queue experience, is around 10 minutes, with top speeds of the ride vehicle being around 4 miles an hour, and our hourly capacity is right around 1,400.
This is the facade for the Institute of Interstellar Innovation, which was established to showcase the inventions and history of the Gate Expo. The main showroom is housed on the left part of the building, and the entrance and courtyard area are on the right side under the clear dome. The queue is housed on the second story inside the wave-like form of the building.
Right, so we'd like to take you guys first through typical guest experience for our attraction, all the way through entering the facade, which you just saw, to unload. So the experience begins in the courtyard, as Jack mentioned. You enter on the left side beneath the Cosmic Countdown sign into this open air courtyard. On top of it is a clear glass dome, and there's a lot of vegetation to kind of counteract all the chrome that's been used in the facade and in the interior. So there's plenty of vegetation in this open air courtyard and a fountain in the middle where you can see the exit and entrance routes. From there, you'll take stairs up to the second floor where our main queue is housed.
Here is our AutoCAD layout of the queue. I'll quickly address some of the safety standards that we took into account. The queue path itself has a minimum clear width of 36 inches and clear length of 48 inches. Door openings are a minimum of 32 inches wide. At least 2 exits are a minimum separation distance of 1/2 the length of the maximum overall dimensions of the queue area. The layout itself has no 180-degree turns, only going as far as 90 degrees. Our queue features a unique no-touch interactive system. Guests are given 3D printed wristbands, shown here as a SolidWorks part. At the wristband dispenser that's displayed in blue and black at the beginning of the layout, the wristband is made of a flexible filament and is intended to be reusable as well. The dispensers have visual graphics that can easily explain the interactive component for guests. Guests will hover their wristband across these glowing spots on the interactive walls. These glowing spots could either be red, blue, or yellow. Only matching corresponding wristband colors will be able to activate them. This is possible through the use of photoelectric diffuse proximity sensors. After each activation by a certain amount of guests, the power cores at each holographic projection, labeled 6 on the layout, will grow with intensity until it activates the projection effect itself. There will also be some large physical prop/set areas consisting of inventions from the first gate collaboration connecting the ride and the queue more explicitly. These inventions themselves work hand in hand with the projections to build context, priming guests for the experience they're about to step into. The projections give some background on what each invention does and builds on the first gate collaboration. By establishing the new norm in the queue, riders can fully immerse themselves before stepping onto the ride itself. Altogether, the elements in the queue introduce the guest to the attraction in bite-sized components with just a wave of their wrist.
So
Lastly, we
after,
have,
sorry,
yeah, yes.
go ahead.
Lastly, we have our theoretical facility impact sheet. This sheet takes into account how each component of the queue interacts with the facility itself. Considerations such as facility wall blockages, power sources, attachment methods, control sources, and element dimensions are determined with each individual component. These dimensions were also derived from the AutoCAD layout directly for consistency as well.
So after going through our immersive queue, you'll take stairs down to our loading platform where you'll first see our vehicle. So like I said before, it's an EMV tracked vehicle with a hexapod that's shown here in the bottom right, with 6 electric actuators that allow for 6 degrees of freedom. And the reason we wanted to include this was, of course, time traveling is not a smooth ride. There's going to be some bumps along the way, along your adventure. So we just want to give a little excitement and fun moments along the attraction. The main vehicle is made of aluminum A60 composite. It's relatively strong, so it can handle high load capacity, but also decreases the weight that's put onto the base of the vehicle. So we want to go for a more vintage vibe relative to the retro futurism of the rest of the park. So we found these car types called Norman Tibbs cars that look retro futuristic, but also antique. So it kind of fits in with the whole Time Travel Institute feeling that we're going for. As you can see on the top right in the exploded view, you can see the 6 electric actuators and then the top ring that the vehicle chassis sits on. So this is our final vehicle concept. There's 3 rows of 4 seats each to have 12 guests on any one vehicle. You can see the hexapod base under the shell assembly and then the tracked base. So we did some basic vehicle research and we determined that there would be 4 main components to our vehicle. The bogies, which would act using a guide rail to guide the vehicles along the track, the turntable system, which sits in the base and it allows 360 degrees of motion for the vehicle. The reason we included that was we wanted a very immersive environment in our ride. We want guests to be immersed in the time travel in the world of Stargrove. So allowing them to not just see a flat scene cutout, but to be able to rotate around and see the sets from all angles really adds to the believability. The electric actuators, like I said, add little fun movements to the ride, and the rigid chassis sits on top. So we're dealing with around 20-inch wide seats, which is pretty standard. We worked with a 13-foot clearance with the entire ride vehicle taking up around 12 feet by 9 feet. You can see an exploded view of the parts I just described in the bottom right. Then also, since we're doing an EMV ride, we wanted to have some basic vehicle animation to show you typical, jolts that we can give guests to create fun moments. Here's a little shorter one of it going to the left, a little bit forward from the top view. And then again, you can see how the actuators are working to create that movement from below, along with the turntable being able to rotate it.
All right, for our layout, some background info here. So the light blue on the top is our outdoor courtyard area for the entrance and exit. These 2 dark gray areas are the unload on the left, load on the right, and then the rest of the show scenes that are blocked off are colored in a heat map that's supposed to show like a guest experience excitement level. So with like deep red being the most exciting scene, and then like a blue or purple being the least exciting. So we start here in this oval shape, which is our dual loading center. So there's a lot quicker loading here with the 2, allows our throughput to be a lot higher and more efficient. They start here, go through our turntable, which Liam will talk about more. They go through here, which allows for multiple cars, about 3 groups, to view one scene at a time and turn through. They come through a transition here, which is like our star field, and show up in the yellow section down here in the jungle, which is supposed to show like early alien life. And then they come through a little transition point down here in the green to a factory and farmhouse. And that will lead to kind of start to see like the production of the city, and it will lead into a more futuristic city here in the red. We decided to go for like a very expansive show set to show off like a really deep city, and so they can get a feel of scale. And then they travel here through this little light green area, which is our media room, and back through the city and into the lab down here in the blue. And then they are moving into a night scene of the city so they can see it from a different view. And then they move over here into the small little green, which is our help beacon for the story, and moving into a factory right here in the orange, and then move up through like a celebration and warehouse scene, and then to our unload section here. Some unique features that we had to deal with is in order to optimize and maximize our space for the track, we decided to move our queue upstairs. So while they enter through on the first floor for the outdoor area, they come up pretty much stairs right here on the entrance. And so they go to a second floor queue. That way we can use pretty much the entire first floor for track. And then they'll come downstairs into the dual loading area. And that is it for the layout.
This is our dual loading area with small gardens growing the Adox berry, a focal point of our story, and a large statue of Professor Flabigus, the main character of our ride. Guests will board their vehicles and are then motioned into the professor's study. Inside the study, Professor Flabigus debriefs the guests on their time travel back to key points of the planet's history in order to learn of Gate Expo's origins. This room also showcases a holographic effect, showing the planet and time the guests are traveling to. The ride vehicle then backs out of the room through an LED starfield into a dark, mysterious jungle. Inside this prehistoric jungle, the guests get close-up encounters with the flora and fauna of the planet, its early inhabitants, and most importantly, guests get their first look of the glowing Adox berry in the wild, the planet's main energy source. Guests then time jump into a factory in the future. Inside this factory, they see the Adox berry being farmed and processed for its energy, as well as a young Professor Flabigus explaining the scientific properties of the berry and its use in their society. Guests then exit the factory and pass through the city gates, where they are met with an expansive, shining cityscape with large domed houses and brightly colored advertisements. The entire city is powered by the Adox berry, and the guests start to see the abuse of this natural resource. They then take a sharp turn onto a freeway into the shopping district, where they see flying cars zoom past them and get a closer look at the citizens of the city and their highly indulgent lifestyle.
And after exploring this glamorous city, guests come upon the scientists running around panicking, and it is here that they find out that the aliens have used too much of their power and resources, that they are about to run out. So guests soon leave that room and enter a dinner party with the alien elite. But the celebration is short-lived because the skyline starts losing lights, and there's an entire blackout across the scene, and the aliens soon panic. So guests are quickly rushed out of that room and come upon the scientists once again, signaling for help. So the scientist activates a beacon, and we see spaceships coming all from directions and congregating upon this planet to come up with a solution. So then guests are congregating at the factory along with different aliens, and we see this giant collaborative effort of people constructing and soldering and just engineering a solution as quick as possible. And by the end of this scene, guests find the new invention that's connected to the whole city, and they exit the power plant, seeing the city being lit back up and the entire planet celebrating that they once again have power. And it is here where we realize that these scientists plan to meet again year after year. And that is the story of how this whole Stargrove and this GATE program started.
Then the professor will send guests back through a star field similar to the Star of Our Journey, back to the Institute, where they'll unload and have other adventures in Stargrove. So after taking you through a typical guest experience, we wanted to showcase and focus on one scene. That would be the professor's study, one of the first scenes in the attraction, and try and bring it and use our skills to develop it as fully as possible. So it started with our initial idea, a simple story beat of what the scene could be. So we knew it'd be some professor introducing the guest in his office and then instructing them and sending them back in time on their adventure.
And from this idea, we were able to come up with a script, and that we used to inform just what kind of visuals we were trying to use and just to set the tone. Because as Liam was mentioning earlier, this is sort of an introduction of the space adventure. So we wanted to start off kind of very like regal and calm before the excitement builds up later.
So we then worked on, or Jack worked on, some early concept art for what the scene could look like and some possibilities. We knew we would want an animatronic professor character in the middle of the room standing on a futuristic base that provides the scrim for the effect where you see the planet you're going to and time travel. Originally, we were going to use it as sort of an observatory scene with screen windows on the top along the ceiling, and you would make, the vehicle would make a semicircle motion entering on the right and exiting on the left, kind of rotating around the professor character. So after that, we tried to make some 3D models in SketchUp and Blender. I tried to map out the space and some possibilities of constrictions like ride constraints and clearance envelopes to see how big the show building for this one scene would have to be. Then Brian worked in Blender and took it a step further, and adding the windows and the doorways and the monkey head as a stand-in for the animatronic professor. But we soon came upon a problem because we wanted this long exposition scene where the guests are starting to be immersed in their environment, accepting that time travel is possible and learning about the professor and his institute. Obviously, that's going to be somewhat of a longer scene. So how can we create a 1 to 2 minute long scene using exposition that doesn't affect our ride capacity? So the solution we came upon was a turntable system for this specific scene. So the way it works is there'll be 4 identical sets on this turntable divided by set dividers. So just copy and paste 4 times of the professor's office, the professor's animatronic, the entire set. So at any one time, 4 individual vehicles can be viewing the scene at different times in the scene, while also allowing for an increased output. So the main components we have are the set dividers, as I mentioned, some vinyl flooring on top of the turntable that spins at the same speed the ride vehicles move at. The wooden spokes, which is our main support system inside the turntable because it's relatively lightweight for being so strong. An aluminum shell that would attach to the caster wheels, which do most of the supporting and allow it to turn, along with a ball bearing on the bottom that translates that rotational motion to static, and then a bevel gear pinion system attached to a DC motor that would power the entire system. So the caster wheels specifically hold up to 40,000 pounds each, and there is a manufacturer that makes these specific types of wheels. It's a 3-foot diameter, so relatively big. The ball bearing itself, the way it works is there's 8 steel balls constrained by 2 steel rings, and it's able to translate that rotational motion from the central shaft into static, so it's able to be supported. Then the bevel gear system is made up of a large gear and a smaller pinion, and that's able to rotate the turntable vertically from that horizontal motion that's driven by the DC motor. So the biggest thing when we were designing the turntable was weight considerations, because it's around 50 feet in diameter. It's pretty heavy. So it weighs about 206,000 pounds. Before it weighed around 2.8 million, but then we replaced the material with wood to make it lighter weight, so it's easier to support. The caster wheels each support around 40,000 pounds, like I mentioned earlier, but we took into account a factor of safety of 2, which is relatively high. So it's a very safe system. And then the total weight that needs to be supported is around 236,000, which is still under that maximum capacity of 240,000. And I have an animation of showing the different parts that go into the turntable. So that aluminum shell, that's 3 inches thick, the wooden spokes, and then the vinyl flooring. So here's a stripped down animation of the turntable working with the gears and the shafts before we add facility space and walls. And then we made a drawing sheet dimensioning how big this turntable would need to be. It's around 42 feet in diameter. The show set depth is around 20 feet deep, which is a decent amount for 4 identical sets. And it's around 40 feet in height. So this would sit on the first floor where the caster wheels are, and then this would go into a below ground maintenance facility for the gear and pinion system. So this is what the final product looks like with facility space and the bus bar track added. And then with that added, this is what it would look like from a top-down view of it rotating, relatively slow, around 0.1 RPM to get a little bit of a longer scene. And then this is a final animation showing the vehicles moving in. So it works kind of like a rotating glass door, where one vehicle moves in to start the show scene just as one moves out into the Starfield room to begin their time travel adventure. All the while, 2 other vehicles are watching the scene at different points in time. So it all works together to create a long exposition scene that's important to our story, but also allowing for an increased hourly capacity.
So to develop this scene further, we took Jack's sketch and I put it into Blender and slowly added details, and we went back and forth just trying to figure out what kind of props we would like to have on this scene. And we also took the same model that Liam came up with and made sure that everything fit into that scale. And that was, yeah, the animatronic is also like a standard size. And if we check the next slide, you can see what the final result looked like. This was also just made in Blender, and it's just a simple model, and we can develop that further if we'd like. And if you see the next slide, you can see some more detail on the character sculpt. And this is based off of the concept art from D'Angelo. And yeah, it's just the alien professor who will be greeting guests and just introducing them to the story. And if we take a look at the next slide, this is a blowout of the scene, and it's easier to see exactly what props are involved. And this, you can look at the codes, and that translates to the facility impact sheet that's on the next slide. And here, every single prop is isolated, and its purpose and its needs are placed to the right. And this way, people who are involved in the project can see exactly who's in charge of what item in this show scene, because it's going to presumably be a lot of people involved. And that's it. Thank you very much for your time, everyone.
We just want to end by saying thank you to our mentor, Jeff, who always made time to meet with us and give us valuable advice, and the whole STEP team, especially the management team, for putting this project together. I personally have had an amazing time working on this, and I'm really proud of what we created and met some wonderful people. So thank you, everyone, for listening.